Hello everybody, in this video we'll be looking at the tetration of x. And what is a tetration? A tetration can be denoted like this. There's no formal notation yet. It can be noted as this, or it can be denoted as this, I believe, with two up arrows. I'm not exactly sure how you can denote it, but this is the version I like to use. And what this actually is x to the x, because we can generalize this now and we can say that the yth tetration of x, that's going to be x to the, let's just write it like this. We have x to the x dot dot dot, and this is all happening y times. So we can see that this is some crazy kind of exponential like function that grows crazily fast. But in today's video, what we'll be asking ourselves is what is the derivative of the tetration of x? Like so. What is this right here? And the way that we can do that is we can actually do it using implicit differentiation, which I'll be covering more on my channel. So what we can say here is we can say that y, and then let's just write this in notation that we know that's going to be x to the x, because that is the x tetrated to 2. And what we can do here is we can use the property of the natural logarithm, where if we take the natural logarithm on both sides, so that is like so, you will get on this side the natural log of y, that's going to be equal to, and then we can actually, taking the natural log of x to the x, we can bring the exponent down and then multiply it by the natural log of the base. So this is actually going to be equal to x times the natural log of x. So what we can do now is, because, and the reason why we do this is because we're trying to find the derivative of x to the x. So taking d by dx on both sides is not helpful at all, because this is essentially literally what we're trying to find. So now what we can do is we can actually take the derivative. So we know the derivative of y is, the derivative of natural log of x is 1 over y, but remember we have to multiply by dy by dx, because dy by dx is because y is a function of x. And just a note here, in implicit differentiation, our goal, our want, is to find dy by dx, because we have some function y and we want to find the derivative of y with respect to x. And of course here our function is x to the x. So let's continue. We have now the derivative of this. We see that we have a product of two functions, so therefore we need to use the product rule. So we have the derivative of the first times the, and keep the second, and then we add the derivative of the second, which is 1 over x, times the derivative, and then keep the first. So, and of course you can derive this using implicit differentiation itself, which is really cool. And this is a exercise that I'll leave to the viewers here. We can actually see that if we set y to be some f of x times g of x, you can actually use implicit differentiation to figure out to derive the product rule. So that's pretty cool. But anyways, let's continue here. So we know that now we have 1 over y dy by dx, and we can do some simplification here. 1 times ln x is just ln x, and then this x over x is just 1, so plus 1. And what we'll do now is we'll multiply by, so we have this here, let's multiply by y on both sides. So what we'll see is that this and this will cancel, and therefore we'll be left with dy by dx, which is what we're trying to find. So this is a good step, is equal to y times 1 plus ln x. But are we done yet? No, because we still have a y in there. So we still have now dy by dx. That's going to be equal to, and well, we have a y here, but what is y? Y is x to the x. So we have now x to the x all times 1 plus ln of x. And that is the derivative of the tetration of x, which is pretty cool. And let's look at another example of this, where we now have y is the third tetration of x. So this is actually equal to x to the x to the x. So let's just compute this one now. So let's do the same steps. We have the natural log of y, that's going to be equal to x to the x times the natural log of x. So this is getting a bit complicated here. So taking the derivative on both sides, we see that 1 over y dy by dx is equal to, and then the reason why we computed the first one is because now we can actually use this to compute the third tetration, because what we need to do is we need to take the derivative of x to the x, which is x to the x times 1 plus ln x. So we have x to the x times 1 plus ln x, and then we keep the second, so I'll keep it like this, ln x, and then we add, keeping the first times the derivative of ln x, which is 1 over x, so that's over x. So what we can do now, multiply by y on both sides, we see that dy by dx is going to be y all times. Here we can distribute this, we can distribute the natural log into this right here, but keep the x to the x factored out. So what we see here is that we can actually even factor out an x to the x to this entire thing, because we have an x to the x here and here. So we have y and then x to the x factored out again, and distributing these natural log, we have natural log of x plus natural log of x squared, so ln squared x, plus 1 over x, because that is our term here. So what we do now is we see that y is x to the x to the x. So what we see here is that dy by dx, it's just going to be equal to x to the x to the x times x to the x, because this is all factored out anyways, and this is now, here we can write it like this: 1 over x plus ln x plus ln squared x. So that is the third tetration of the of x. So that was pretty cool, and I hope you guys enjoyed this video. So thank you for watching.